Alright, this is my third take of my chapter 17 video assignment because I keep messing up my terminology. But basically what we have is a chart of half-reaction cell potentials. There it is. Question 1 is split up into two parts. First part is which substance is the strongest reducing agent. And basically that means is what is the oxidation part of your reaction, and whatever has the smallest cell potential, that is going to be the thing that's being oxidized, because it doesn't want to hold on to its electrons as hard as the other thing it's being compared to. And for that, I did D minus because it has a small cell potential, but it also says consider all substances, both reactants and products. And I'm not sure if that means that, let's say, this top half reaction here, if that could be flipped around, basically saying that A plus has the strongest reducing agent. I'm just not sure about that, but that seems like maybe that could be a possibility. But anyways, the second half of part 1 is which substance is the strongest oxidizing agent, and so that's just going to be whichever thing has the highest cell potential, and that's the one I was just talking about, the A3 plus 2E. It's a 1.47, and that's the highest cell potential we have. So it's going to be your oxidizing agent, or the thing that's being reduced. So it's a little complicated there when you think about it. Number 2 is which substances can be spontaneously easily oxidized by B2, or B with a +2 charge. And basically what that means is, what is that going to take electrons from? So anything that has a lower cell potential than that, it should be able to take electrons from. So what I said was C plus and D minus, because they both have lower cell potentials than the B2 half reaction, should be able to be oxidized by that. And then the second half to question 2 is which can be spontaneously reduced by C plus. And so that's going to be anything that is higher cell potential than C plus. And so I said B2 plus and A3 plus can be reduced. So they will be getting electrons from C plus, which you can see here. Imagine this reaction going backwards, and then these two gaining the electrons from that. And then number 3, write a balanced equation for the overall reaction that delivers the highest voltage. And so here I have written out, basically you're going to want the greatest difference, in cell potential. So I picked A3 plus, and then the D minus. So basically you're going to be having a D minus. It's going to be giving up electrons to the A element, therefore reducing it. And so the D is the thing that's being oxidized here. But actually we need, a D only gives 1 electron, so we do have to balance it a little bit. And the A needs 2 electrons to become the A plus, which is what we have the cell potential for. So we need to make sure that this is getting enough electrons. So all we have to do is just make sure there's 2 moles of D minus per mole of A3 plus, and then you will have enough electrons for the reaction. And so that's my balance. I don't know if we were supposed to write down the electrons in that, but I feel like I explained it. And then we have to calculate the E, and that's easy. We just take the cathode minus the cathode minus the anode. And so our cathode is the thing that is being reduced. So we have here 1.47. It's gaining the electrons, it's being reduced. And then minus the anode, and our anode cell potential is actually negative. And that's being oxidized, it's giving up the electrons, and so it's actually going to be a positive number. So you're just going to add them together, and for that I got 2.85 volts. And that was kind of a long video, but I hope I explained it well enough.